Let's test your understanding with variations. If we double the wall thickness of the brace from 25 mm to 50 mm, how does that affect the plastic moment? If we double the wall thickness of the brace from 25 mm to 50 mm, how does that affect the plastic moment MP? Since MP equal to Fy by Fy t squared by 4, doubling T means T squared goes up by 4. So MP quadruples. Exactly, the plastic moment is very sensitive to thickness. What about the denting force PD using furnace formula? If T doubles, if T is doubled, you can see the MP quadruples and D by T becomes 1 by square root times the original. Then, so overall, the PD becomes almost 2.83 times. So original force. So PD almost triples. So if we double the thickness, PD almost triples. Thickness increase greatly improves the resistance, dent resistance. Thickness increase greatly improves the dent resistance. Now try Linus formula for the same change. Now try Linus formula from the same change. How does PD change with double thickness? How does PD change with doubled thickness? So if thickness doubling T means T square goes up by 4. Doubling T means T square goes up by 4. So PD quadruples. Right, Helena's formula shows even greater resistance, even stronger dependence on thickness. Helena's formula shows even stronger dependence on thickness, a stronger dependence on the thickness. PD has a stronger dependence on the thickness. If we double the thickness, T squared goes up by 4. T squared goes up by 4. So PD quadruples. Let's compare the energy absorbed for 25 mm to 50 mm thickness using. So put this value of 25 mm and 50 mm, compare the ED value with 50 mm watts energy and 25 watts energy. 3.57 it will be getting removed. So to the power 3 by 2 when you take. So X stays as 0.1 meter. How does energy change? If dent depth X stays 0.1 meter, if X dent depth stays 0.1 meter, how does energy change? So you can calculate the ratio. You can see that it's almost 2 triples. Energy absorbed almost triples. So if we change the thickness if we are doubling the thickness, energy absorbed almost triples. Energy absorbed almost triples. If T doubles, energy absorbed almost triples. With the X is the dent depth, that stays 0.1 meter like that. So increasing the thickness is a powerful way to improve dent resistance. But watch, wait and cost. What if the dent depth X increases from 0.1 meter to 0.2 meter? How does dent energy change? How does dent energy change if dent depth? What if the dent depth increases from? What if dent depth X increases from 0.1 meter to 0.2 meter? How does that affect the dent energy, or how does dent energy change? Same formula, energy scales with X power 3 by 2. So energy scales with dent depth power 3 by 2. Energy scales with dent depth power 3 by 2. So 0.2, 0.1 power 1.5 means it becomes almost triples. So doubling dent depth nearly triples energy required. Doubling dent depth nearly triples energy required. Nearly triples the energy required. So dent depth matters a lot for energy absorption. Dent depth X matters a lot for energy absorption. Matters a lot for energy. Let's try an example with B ratio. Brace diameter 0.9, wall thickness 24 mm, yield value. So calculate the dent energy if B equal to 4, if B equal to 8. So B equal to 4 means deep dent. So we have the deep dent, that's B is 4, and we have the B is 8. So that's a shallow dent. So use this formula, ED equal 3.54, you will get the energy value. So with B equal to 4, you are getting 484 kilojoule. B equal to 8, you are getting 172 kilojoule. So notice that energy needed for denting at B equal to 4, it's nearly 3 times B equal to 8. Deeper dents take much more energy. So if a vessel impact energy 5 megajoule and a single brace absorbs 0.2, how many braces must we absorb the energy to survive? So it's almost 25 braces. In reality, not all braces share the load equally, so safety factors apply.